right, so we've got 2x minus y equals 4. If I'm looking for my x-intercept, that means I've got some value of x, it's crossing x somewhere, and y is 0. So if I plug in 0 for y right here, okay, that's going to go away. I'm left with 2x equals 4, so x is 2. Now if I plug that into the equation though, I'm going to have 2x minus y, which is 0, equals 4. So 2x equals 4, divide by 2, x equals 2. Okay? Okay, same thing with the y-intercept. Okay, the x value is 0. My y-intercept, the y value I don't know yet. So if I plug in 0 for x, I get negative y equals 4. So y is going to equal negative 4, right? But I'll plug that in. So I've got 2 times 0 minus y equals 4. Negative y equals 4. And if I multiply both sides by negative 1, I get y equals negative 4. So my y-intercept is negative 4. And I just like this because it connects the dots. All right. Lastly, now not all equations in standard form work out this nicely. Sometimes, and a lot of the times, your x and y intercepts will be fractions. But these examples that I'm using, the x and y intercepts are whole numbers, so that's kind of nice. Okay. So right here I've got x plus 3y equals negative 9. If I'm looking for my y-intercept, then y is going to be, or x is going to be something, y is 0. So x plus 3 times 0 equals negative 9. So x is negative 9. And I can also cover that up again, right? If y is 0, that makes this 0, it goes away, and I see x equals negative 9. Let's clear down here. Okay, my y-intercept, remember, x is 0, y is I don't know yet. And when I plug in 0 for x, okay, I get 0 plus 3y equals negative 9. This is what I have. So y is negative 3. So I keep going here. Y equals negative 3. Okay. Whoops, didn't quite go right there. Okay. Finally, we have a story problem. And I hope that the graph of this, I hope this makes sense. Okay, but what we've got here, it says you're planning an awards banquet for your school. You need to rent tables to seat 180 people. There are 2 table sizes available. Small tables seat 6 people and large tables seat 10 people. Okay, the equation 6x plus 10y equals 180 models the situation. So we don't have to come up with the equation. Okay, where x is the number of small tables, y is the number of large tables. So we want to graph the equation and interpret the intercepts. Okay, so we've got 6x plus 10y equals 180. All right, if I am looking for the x-intercept, remember that I don't know what x is yet, but my y value is 0. So I have 6x plus 10 times 0 equals 180. So 6x equals 180 divided by 6, x equals 30. Now I don't have any numbers on this number line, so I think I'll go by, I'll go by 2's. No, I'll go by 5s. Every 2 is 5. So 5, 10, 15, 20, 25. Here's 30. Okay, so x30 is my y-intercept. I mean my x-intercept. My y-intercept is where x is 0. So when I plug in x for 0, I have 6 times 0 plus 10y equals 180. Okay, so this is going to be 10y equals 180. So y is 18. Okay, that actually makes me want to switch this. I'm going to make this into 2. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So now 30 is right here. And this way we have 2, 4, 6, 8, 10, 12, 14, 16. Here's 18. That's my y-intercept. Okay, so graph the equation and interpret the intercepts. Okay, so what's happening here? Oops, my finger got in the way. What's happening here is what if we only got, if we have 0 tables of the x value, if we have 0 6-people tables, then we can get 10 we can get 18 tables and we can fit 10 people. So this right here is if we only get 10 people tables. We would need 18 of them. Now the other side is, what if we only got small tables? Okay, then we would need 30 of them. So this is if we only get 6-people tables. So we've got 2 extremes here. We can either get all small tables and get 30 of them, or we can get all large tables and get 18 of them. But somewhere there is a happy medium, and this is where we look at the graph and we look to see where it crosses some of these other places so that we know where we might have a combination. And it's hard to tell on this graph. I think I'm going to say, actually I'm going to pause for just a second, and I'm going to just look at this graph a little bit better. It's really blurry. So, all right, so that gave me a second to look at my graph a little bit closer. It's a little bit blurry. So, so these dots that I've put here are where the line crosses in the exact spot, right smack in the at the corner, or where these intersect, I should say. Okay, so another option that we have here is if we have 2, 4, 6, 8, 10, 12, nope, just kidding, 10. And we have 2, 4, 6, 8, 10, 12, 12. So one of our options that would also work is if we had, because it says find 4 possible solutions in the context of the problem. So we could have 0 and 18. We could have 0 small tables, 18 large tables. We could also have 10 large tables. No, just kidding, 10 small tables, 12 large tables. Down here we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And here we have 2, 4, 6. We could have 20 large tables, 6 small tables, and then of course we could also have 30 small tables and no large tables. But I'm not going to have any I'm not going to have 7 large tables and something else. I'm going to seat exactly 180 people. So these are my only options. All right, that is what I've got for you. Your homework is here. This is a Halloween cartoon. Sorry, I know I'm kind of late. But anyway, here's your assignment. It's on big ideas. If you have any questions, please come see me during consultation, or you can email me or whatever, but please let me know.